Alright, so this time we're going to talk about energy, which has three basic forms, which are kinetic, potential, and internal or chemical. We're not going to talk about that because it's not really related to Newtonian physics. It kind of is. If you get into electricity and pumps and motors and that sort of thing, but I'm not going to go over it. So kinetic energy is the first one, and that is the energy an object has because it is in motion, and it is equal to 1/2 mv squared. M is the mass of the object, and this is the velocity of the object. This velocity is independent of the direction, so if somebody, say, throws a ball and it's traveling in a parabola like this, and you have the velocity in this direction, it has two components. It has a y component and it has an x component. You want this velocity, which is the overall velocity, the magnitude of that. And we're going to ignore that my friend is over here playing Warframe. The second is potential energy, and that is equal to mgh, which is if you have an object in a gravitational field at a height of h, that's gravity on Earth, has a mass. Yep. So m, mass of object, g equals gravitational acceleration, and h equals the distance through which it can move. So for example, if you have an object here that can fall this far, and an object here that can fall this far, this one has greater potential energy than the other, because this one cannot fall nearly as far. There is another type of potential energy that is spring potential energy. So you have Hooke's law, which is equal to F equals xk, where if you have a spring, and this is its resting position, this is defined as x equals 0. And then if you stretch it out per se, this is x. So the force exerted by the spring is equal to xk, where k is the spring constant. Actually, I should write that in print. And likewise, for the energy stored in a spring, potential energy is equal to 1/2 k x squared, where x is displacement from the resting position. And that's pretty much it.